So you think you're hard enough, do you? Well, this is a way of gauging how hard you are. Now, you're all, of course, aware of the Mohs scale of hardness. We covered this in the mineralogy lecture. It's quite useful. It's a measurement of a scratch. Can you scratch it with something? There's also quite often used in metallurgy, and yes, this lecture is about metals, indentation, in which you determine how much weight it takes to make an indentation in the substance you're working at the hardness from. And there's a technique developed by a man called Brunel, and there's a technique developed by some people at the work for Vickers. This is a Vickers gun from about the First World War. Quite often you see these numbers reported as megapascal pressure units, MPAs. So this is a useful little graphic, which I don't expect you to memorize, showing you the major metals. So many of these metals were known in the ancient world. Some were unknown, however they were used, and so that makes them relevant. Gold, we were talking in the last lecture about gold quite a lot, is not the least abundant, but it's the 72nd least abundant, or most abundant, I guess, element in the Earth's crust. It has a hardness of 2.5, which is quite soft. An important aspect of metals is how you get them to melt at lower temperature. And I showed you in the last lecture how if you add copper to gold, it will melt at a much lower temperature. It may appear obvious that if you add tin to copper, it may melt at a lower temperature, but actually you see these have quite a similar temperature, but you can get it down a couple of 100 degrees by putting the two together, which probably only makes sense to physicists. An important aspect of the metals is their hardness, especially if you want to turn it into something you want to hit somebody with. And so here you can see the Mohs hardness, and the hardest is iron. However, what is useful about these other hardness tests is they show you the range of hardness, and it's actually possible for things like copper to have quite a wide range of hardness. And there are all sorts of things ancient peoples did to copper in order to make them harder, which in many ways we have no way of figuring out how they did them. Iron, which we will cover in the next lecture, is the fourth most abundant element in the Earth's crust. It's actually the most abundant element in the entire Earth because most of the core and mantle has iron in it. You can see it's a much higher temperature of melting. And so it's very different from all these other things which you can smelt, which is a way of melting. It's a smelt, you know. And will require a completely different technique, which is one of the reasons we'll talk about it in the next lecture. So, silver. Let's talk a bit about silver. So you do have native silver, but it's very rare. Argentite, the silver sulfide, is a far more common element, source I should say. It's not an element, it's a mineral. And you often get this associated with the lead sulfide, galena. So the close association with lead and silver means you have to separate them, which we'll cover later on. Sarargerite is a silver chloride, which is in altered lead sulfide deposits. So what you'll do in this case is you'll smelt the lead ore and then cupellate the lead out of it to leave the silver behind. So that's two things we'll have to talk a bit more about. Let's talk first about smelting. Smelting, this is quite a nice smelter. This is actually a lead smelter. It's from Iran. It's in the Wolf book. And if we make it a bit nicer, you can see that it's basically made of pottery. It's going to be clay, built up in slabs and coils and things like that. This is probably about 2 feet high, 60 centimeters or so. And you basically make this big pot partly into the ground to keep it hot. You may then want to add a toyer with bellows. There you can also use a blowpipe or something like this to create more air coming into your furnace. You may also want to add a tap hole. Here's the tap hole down here. This will be bunged up for most of the smelt, but this will come into use later on, possibly. So once you've built your furnace, you will want to add carbon fuel. And so this probably in the ancient world would be plant-based, like charcoal, which is a way of processing plants into being used for materials like this, which we shall talk a bit more when we talk about plants. And of course your ore. And following the last lecture when I talked about beneficiation and improving your ore, this will often be oxides. If you have a lot of silica in your ore, you might want to add limestone, which will act as a flux, and we shall get to that. So then you'll heat it up, set fire to all that carbon, you'll blow into it to get high temperature, and you'll have a smelt going on. So this is more than just melting the metal out of the ore, because you will have carbon monoxide being generated by burning the carbon fuel, as of course we know very much about now, well, because of global warming. The carbon monoxide will pass up into the ore zone, where it will gain oxygen from those oxide ores to make carbon dioxide, and this will actually leave. So as the carbon monoxide is being released from the firing, it's not just a matter of heating it up, it's also dragging the oxygen out of it as it goes. Also, if there is silica in your ore and you've added the limestone, those two things will go together. So if you remember the lectures about glass and glazes, you will know that the lime acts on the silica to make it melt at a lower temperature. This is called slag, and this is what you might want to run off through this tap hole. So here's your pool of slag. So after that, you have metal. That will require further processing. In the case of silver, we'll get to that now. So cupellation, you take that piece of metal and you will melt it again. So lead melts at 327 degrees centigrade, lead oxide at 888 degrees centigrade, and silver melts at 960 degrees centigrade. So lead will want to melt before the silver does. So what you do is you melt the alloy in an oxidizing environment. The lead oxidizes to lead monoxide, which is called litharge, and it will be absorbed by the cupel. This is a cupel, the first bit of this word, cupellation, and this absorbs the lead from this mix of lead and silver, and what is left is the silver. And so that's how you separate lead from silver. So silver is a very important material in the archaeological record. It tends not to be commonly found in archaeological sites because, of course, it is a precious metal, and how you find it is actually in a hoard, most likely. This is the Rogozin treasure, found in Bulgaria by ploughmen. And then archaeologists came and found some more. I think like 160 of these things were found and cleaned up and then put in a pile again. I think many of my museum colleagues would be horrified to see these very old, very valuable silver objects just piled up on top of each other, but let's not worry about that. And as you can see, they had some very nice objects in there. So there's also a well-known group of silver plates from Sasanian Iran, although I don't know if they were found together in a hoard or how they actually got into the market and into major museums, like this one's at the Met. But they're very nice. They are mercury gilded. Remember I told you about mixing gold with mercury, and then you heat it up and that drives the mercury off and it leaves the gold behind. Silver and gold, of course, quite like each other, so you don't need anything to bond them together. And here's another one of these Sasanian plates. This one's at the British Museum. And this one's also at the British Museum. As you can see here, it says Sasanian king being very unpleasant to this line. This is from another group. This is known as the Caper Caroan treasure. Caper Caroan is the Greek name. This was Greek at the time, the early 7th century. It's now called Kurin in northern Syria. And this is known because they would inscribe on it that it was dedicated to the church of St. Sergius at Capercaron, but it just appeared on the market, all of them, and there's quite a lot of them. Here's one at the BM, here's one at the Waters Art Museum. And so, some of these things aren't found as hoards, but they must have been a hoard, probably put away at this site in Syria and hidden and then found and dispersed through the market, unfortunately. But probably the most common artifact we will find in the archaeological record made of silver are coins. So coins are made by striking. And so in this you have two dies. Typically you will have this die and you will have the piece of metal called a blank or a flan in the middle, and then another die you make a sandwich and hit it really, really hard with a hammer. You really want to just hit it once, because if you have to take a number of hits, mistakes happen. So here you can see they made this coin, didn't quite do it right, so they hit it again and made a total mess of it. However, it's still a useful coin. I mean, basically what a coin is a piece of valuable metal. And what a coin does is say, I, whoever this is with his face smashed in on this side, tell you that this coin is made of silver and it's worth this much silver. And so the coinage of a country or of a political unit was qualified by the person whose face you see on it. And they will say, yes, this is 100% silver. There's no rubbish in this coin. Believe in it. That didn't always happen, of course. Here's another example of a twice struck coin. And you can see that this double mirroring here thing going on is because they struck it slightly off center the second time. So this is like a lot of columns with words on it. Of course, I'm not expecting you to memorize all of this, but there's a couple of interesting coins in here. This is ancient Greek silver coins and weights, because that's basically what a coin was a weight of an element of silver, typically, or gold or something. Drachma, very important coin, and you still to this day have drachma as a currency in certain parts of the world. The obol was quite an important coin, of course. It's the coin that you paid the ferryman with. Very, very important. Roman coins were also important. The very important Roman coin was the Asarius, also called the As. I like to call it an Asarius. Big bronze coin, originally cast bronze, very large. It had divisions, which are like the everyday currency that you pay for things, and the multiples. And these also became coins. The most famous, of course, are the sestertius and the denarius. Very important coins, and to this day, many currencies in the world are called dinars. If you travel in the Middle East, you'll know a couple of countries that have dinars. This is actually Pompeii, and on the wall of this wine bar, they had this sign that said you could buy a jar of everyday wine for 1 assarius, but a jar of Falerno wine, which is like the best wine you could get in the Roman Italy, was 4 assaria. So just shows you how much you had to pay for a decent jar of wine. Roman weights are also, again, relevant because, again, we're talking about weights of metals being what a coin is. The libra, the pound, is, again, a coin which comes to this day. There are many countries in the world whose currency is the pound. In fact, Canada had a pound up until the mid-19th century. Then they switched to the dollar. And, of course, drachma again. And the shekel. The shekel, also very important coin. I think there's probably still currencies to this day called the shekel, but probably one of the most important ones in history was the Tyrian shekel. The shekel minted in Tyre. And this was a well-regarded coin. Because it has Tyre written on the outside, here it is, people would know this is a good piece of silver. This is really worth its weight in silver. So the Tyrian shekel became very important at places like the temple in Jerusalem. And if you wanted to pay your temple taxes, like any good person from that part of the world would want to do, you would pay your taxes, your temple taxes, in Tyrian shekels. And so what would happen is if you went to the temple to pay your temple taxes, you would need to change your ordinary money into Tyrian shekels. And so money changes were a big thing in the temple in Jerusalem. And so here you can see the money changers being beaten off by this chap called Jesus, who didn't like the idea that they were around in the temple and doing their money changing thing. And so the other famous pieces of silver, the 20 pieces of silver paid to Judas Iscariot here for betraying Jesus, those 20 pieces of silver would have been Tyrian shekels because they came from the temple. Of course, my other favorite thing about this is Peter here, who's cutting this ear off this guy. He's a bit of a troublemaker, Peter. I think he just goes around cutting ears off people. And here's Jesus saying, no, do not cut the ear off that person. So, of course, coins you get in archaeological sites, and you get, again, hoards. This may appear to be slightly out of our way in Sweden, but this hoard of silver coins in Sweden of the Viking era are actually all from the Middle East. You see, these are early Islamic coins, looking a lot like Sasanian coins. This is after they decided, let's not have faces that look like Sasanians on our coins, and like that. Here's another picture of it. You can see it's quite a lot of silver. This is another hoard from out of our area of interest. This is from England, and it's about the same date and includes a lot of silver from Afghanistan. Silver coins from Afghanistan. So also quite interesting. So while we're talking about coins, this is right out of our part of the world. This is a village called Yakimov in the Czech Republic. But in the 17th century, it was also known as Sancta Joachimsthal. The valley, the Tal, you've probably heard of Neanderthal, the valley of the Neander. This is Joachimsthal, the valley of Joachim. In the early 1500s, there was a massive find of silver here at Joachimsthal, and they started minting coins called Joachim's thalers. This, by 1530, they reduced to the name thaler. And this is the origin of that other very well-known unit of currency, the dollar. And so I thought you might like to know that. Not very Middle Eastern, but since I was covering all these other currencies, I'd tell you what that was about. So, lead. Let's talk a bit about lead. Lead isn't a particularly exciting archaeological material. This is kind of cool, though. This is the Ashalim Cave lead object. It's called an object because no one has the faintest idea what it's for. It's a lump of lead on a stick. It's about 22 centimeters long. They radiocarbon dated it. It's about 4000 BC. And they did lead isotopes on the lead and decided it came from Anatolia, which is reasonable because some of the earliest evidence of the use of native lead is from Anatolia. According to the researchers, the artifact was made of almost pure metallic lead, likely smelted from lead ores originating in the Taurus mountain range in Anatolia. So that's kind of fun. I like it. Even more fun are these Roman lead slingshots. So the sling was a great way of shooting heavy things at people, and they would inscribe them with things like ouch. Of course, this isn't Latin, but you know, for Pompey's backside. Take this. Be lodged well. Fruit for dessert, because it looks a bit like a plum or something. This is a hard nut to crack. It also looks a bit like a nut. Here's a sugar plum for you. So, apparently Roman slingers were comedians. Here's a nice big pile of Roman lead slingshots from their attack on a Roman fort. Very far away from the Middle East, but kind of interesting anyway. Another fun things the Romans did with the lead was make curse tablets. And so they would inscribe a curse on this sheet of lead, scroll it up, and then nail it to the wall of a temple. And this was a curse. So if you ever watch the TV series Rome, you'll see that someone actually wrote a lead curse, or a curse on a lead tablet. Kind of fun, actually. So, copper. Let's go on to copper. And of course, people did start off with native copper. There probably won't be a lot of evidence for it because, of course, most metals get melted down. And so people have been using native copper a very long time ago. So you get native copper, where you get copper sulfides being reduced in what is called a gossan, which I'll tell you about in a minute. But you can make artifacts out of it with hammering and heating it up, annealing it at quite high temperature, but, you know, in a fire. And you can make stuff out of it. So this is a gossan. So this is a sulfide, copper iron sulfide deposit. There's a big vein going through the country rock. This is what you'll get in places like Oman and Cyprus, where you have massive copper deposits associated with ophiolite sequences. Remember the oceanic crust thing I kept yammering on about earlier on in the lecture series? This is what that is about. And so you have here, this is the primary mineralization. This is what nature made at first. This is filled with chalcopyrite, which is copper iron sulfide. But up here you get there's leached zones and oxide zones. And up here you have native copper. You have so bright, shiny metallic stuff. You have malachite, bright green stuff. Azurite, bright blue stuff. And also these are quite colourful too. And so up here towards the top you have this very noticeable material, which is very easy to turn into metal. And so what I was showing you last lecture with the mining, you can see how when humans first discovered this deposit, one of the first things they would see would be these very noticeable things, which they could quite easily turn into something usable. As they went down, they ran out of the usable stuff. And so they say, we need to do something to turn this into a metal. And so eventually that's what they did. They followed the lode down. They developed how to smelt chalcopyrite, which of course you will know how to do that now. And Bob's your uncle. So the use of native copper, we first seem to find in Anatolia. Chayanu Tepsi, they have beads and pins of annealed native copper from the end of the 9th millennium BC. At this site, Asicli Hoyuk, beads of native copper from the 8th millennium BC. And at Hatzilar and Khan Hassan here, from the 7th millennium BC. And so this is thought to be where people first started making objects out of native copper. Of course, this is also the focal point of major trade networks at this time, moving obsidian around. So this is where the obsidian was being produced at volcanoes here and then being distributed around this part of the world. So if there was actual trade going on, it's possible that some of the places they were getting the material from was in fact copper. And since this includes Cyprus, maybe that's what was going on here. But I don't know of actually any metallurgist, archaeometallurgist that's come up with that idea, so let's not worry too much about that at the moment. So copper smelting, and you know a bit about smelting now, having seen that thing I did with the graphic, we first get in two places. One's in the Balkans, where between about 5,000 BC to 4,600 BC, you get at these two sites copper smelting. And also in the 5th millennium BC in Iran at these two sites. So these being so far apart has led people to think that there was independent invention in each place. Other people have suggested, in fact, they worked out how to do it in Anatolia first, and it spread to these places. But, you know, it's a problem with very, very rare materials. And these are actually finds of objects. These are finds of the remains of smelting, like hearths and things like this, to actually find manky little dirty holes in the ground and very rare copper artifacts. So this whole thing is probably debatable, and why shouldn't it be? So the first major alloy that we find being used is actually called bronze, but isn't. This is actually a copper arsenic alloy. And this is the dominant alloy from the 4th into the 2nd millennium BC. So early Bronze Age bronze is actually not bronze, it's the copper arsenic alloy. And this is from Anatolia, Iran, and Cyprus. And it has a silvery appearance. In casting, the arsenic will segregate to the surface, making it even more silvery. So that might make it nicer. It improves the casting because it's a deoxidizer, and makes it tougher and harder than native copper is. Very interesting early copper arsenic alloy artifacts is the Nahal Mishmar hoard from the early 4th millennium BC, including like this, called the Crown. It's a round thing, I have no idea what it's used for. And the Standard, so that's 18 centimeters high, could be a standard, could be anything really. So that leads us to bronze, true bronze, which is a copper and tin alloy. So anything above 0.5% of tin would have an effect. It makes the material more gold colored, which is nice, and also harder, which is even better. And at first was mostly used for weapons and prestige artifacts. It reduces the melting temperature. This is pure copper. Add 5% tin, it goes down a bit. Add 10% tin, it goes down quite a bit more. So that's also quite useful. Reduces the melting temperature, and it also is harder. Oh, and there's 15%, so it's even lower. So the dating, we seem to have bronze from the beginning of the early dynastic in Mesopotamia, and early 3rd millennium, that is. And at Ur, by the mid-3rd millennium, a third of the copper alloy objects are bronze, as opposed to copper arsenic alloy. So it's still not actually the Bronze Age, but you can't tell people that. So you also have texts which indicate a tin bronze from the middle of the 3rd millennium BC in Mesopotamia. So that seems to be what's going on. Where they got the tin from seems to be questionable. Afghanistan is an important source of tin, so that might be where they get it from. Of course, also where they were getting lapis lazuli from. So it's funny how these things are often linked. This tin is, these ingots are from the coast of Israel down here. And analysis of these show they actually come from Cornwall. So this is quite a long time ago. And so you can see how they went a long way to get tin. In fact, this tin reserve here may be why the Phoenicians, of course this is probably brought up by Phoenicians, not contemporary Israelites, but it's were traveling all the way around this part of the world, and in later times certainly they came up to Cornwall, and probably that's who was doing this trading. So of course, nice bronze artifacts at the ROM. It's a very old photograph. I should make a new one. So brass is the last copper alloy we'll be talking about. It's a copper zinc alloy. This is closer to gold, so that's kind of desirable. In the ancient times, it was actually called golden copper, orichalcos or orichalcum. There is a natural copper zinc alloy, which has been used since the 3rd millennium BC, but not particularly common, of about 5 to 15% zinc. This wreck, this is from the wreck off of Sicily, about 600 BC, had these orichalcum pieces in it, which were about 15 to 20% zinc. So you can actually make zinc, of course. The problem with it is that zinc melts at 400 or so degrees centigrade. It boils at 900 degrees centigrade, whereas copper melts at 1000 degrees centigrade. So by the time you've melted the copper, the zinc has boiled away. So you can't just like cook them to make them go together. So they developed the cementation method, and this was known by the end of the 1st millennium BC. So that's like before year 1 AD BC. They had developed this. So it's a big thing later on. Copper and zinc are heated together until zinc vapor is produced, which reacts with the copper, making zinc. And this can get 20-28% zinc. So as I was saying, it's a big thing later on. So this is a medieval brass vessel known as the Baptistry of St. Louis, because it's been it was made in Syria or Egypt, but has been in France since the medieval period. And so there's a lot of brass vessels like this. So that's it for now for metals.